Everyone, welcome back to the channel. So today I'll do the episode 1 of a series I'll call architecture reviews. So this is basically a series where people volunteer and give me their consent to go through their database structure. So this includes going through the schema, the indexes, the partitions, everything we've learned on this channel. I'm basically reviewing for free for the sole reason of making these videos for you guys, and basically using all the knowledge I've gathered from every architecture review to make a summary, let's say once a month, to give you the best findings and also the individual findings of each project. So the first project we have is Canada Museum. So the way I got contacted for this is via my website. I will put the link in the description, but if you send your email right here, I'm gonna basically get in contact with you to share me your app, stuff like that, and I'm gonna make the full breakdown of your infrastructure review. What you will get is something like this. So something like a schema health, and then you could get something else like we have something else like scalability, optimization, security, summary for customer, technical validation, and validation queries. So you're getting a bunch of different assets that are actionable and can be implemented pretty fast. So let's start first with this website that we have this morning. So Canada Museum is basically like a kind of a directory listing of Canada museums, and I've got the authorization from the user, the creator, to basically create it. He's a non-technical person. He vibe coded the whole thing, so he's not someone who knows what he's doing necessarily. He used Cloud Code to make the most of it, and basically just a summary of it. It's made with Supabase, so I'm going to show you this right after. So PostgreSQL. There's a few thousand museums in there, and there's a lot of, it's a very data heavy application, so not a lot of users, but there's a lot of data. So museums, calculating distances between museums so other user can find them, stuff like that. There's 18 tables and only 14 megabytes of storage used. It's a small project, but it's still a project that is in production and could be improved, right? So like I said, the owner is not a professional developer. He's, in a totally other field than what he's doing right now. I'll keep his identity hidden as per what he requested. It shows that it's an AI generated schema, but surprisingly, when I look at the schema, it's still pretty well done. I see that there's proper foreign keys, there's proper UUIDs, IDs. There's some good RLS policies already there. PostGIS for location data, because he's basically using location data to like find where the next museum is and stuff like that. So it's pretty well done. So what I'm going to do is I'm going to break down the structure, like I said, and we're going to start with the schema L for this one. And then we'll go into security, performance, and scalability. So let's get started with the schema L right now. All right, guys, so let's get started with the schema L. So this is the kind of report I make for the schema L. Usually I will keep this as, on my side, and then I'll make a summary of all the stuff I saw. I'll make a technical summary and a business summary so that anyone in a company or in an app building team can understand the optimization's potentials. So what I love doing with the entity relationship map. So basically I just outline what is the biggest kind of used relationship. So in this case, most of the projects will have the same thing. So they'll have the relationship between auth users to profiles. And the reason you don't want to use the auth users schema directly in your app is that this schema, the auth, is not exposed through the API, and for a good reason, because it contains like important information. So by only using the profiles table inside the public schema, you basically choose what you want to expose to the end user, right? So it's a safer way. So I was pretty happy when I saw that they had this already implemented with a foreign key back to the auth users on the ID. There was an RLS policies too on institutions and portal tokens for logging. So basically, when a museum wants to sign in and add their museum, they can basically just you can generate a token, send the token to them, and they log in with this, which is a pretty good thing. And yeah, so the profiles is referenced with RLS policies, which I'm pretty happy about. Now, after that, we have the institutions table, which is the central entity. So this is where he stores the museums. So you have the exhibits, which is basically just the foreign key to the exhibits. So it's going to be the main museum. And then after that, you're going to have editors. So who can edit the institution. So like I said, there's a role assigned there. And after that, you get a lot of other parameters. What I want to outline is that those foreign keys are nicely made. They're the same across the board, and they're cascading across the actions. Only not for visitor events, which is not necessarily bad, but is not necessarily good, because you might want to keep user activity information even after the user, let's say, doesn't exist anymore or something. So that's what he's doing right now. So that's maybe something I flagged to him, that if you want to make sure they're removed at the end, you need to cascade it. So that's the first key insight I gave him. And now there's some other standalone tables that are not, there's no link outside of it. So audit log, museum submissions, NHS upgrade stage, partner scans, stuff like that. So those are mostly for, I know these four are mostly for the scraping part, so they don't need to be connected to the actual transactional tables. And then this one is mostly for calculating the distances between point to point on the map for post-GIS, which is pretty nice. Now, I also made a whole primary key audit. So this is basically taking every primary key in every table and basically looking at what's the type and how it's generated and stuff. So as you can see, it's pretty similar across the board. That's what I wanted to see. So using UUID, the only thing, there's a bit of, here we could have an ID with also UUID and generated through the random UUID. That's what I told him. Also here we can see that there's a mismatch. So instead of using a UUID, we're using a big int, which is not the best. We should change this to UUID. And again, same here, unless it's like something like a partner slog where we're using text, which I will still use an ID, to be honest. We should still use UUID, right? So the other thing I told him is those tables would need to have a UUID as the primary key. I wouldn't suggest having a text, a different type for every ID primary key, right? So that's what I basically wrote right here. So institution tags, if we look at institution tags, so we have the ID UUID with the generate random ID, but we have basically a surrogate key that is really unnecessary, that basically combines institution ID and tag ID. But the thing is, you could basically have like just an associative table instead of having a surrogate key, because the problem is, like, a primary key is already unique, right? So you don't need to add a unique constraint on the primary key and the tag ID, because both are already unique, right? So this is basically adding an extra ID column, adding storage. It's not, a bug. It's not crucial, but it's an optimization that can be done. Also, like I said, for the museum submissions, we see that using a big int, right? Which a big int is just a big integer, so it's a full number. And you can see it's not auto-generated, and it's not the same type as the other, right? So what I would do in this situation, and I shared this to him, I'd just alter the table, add the column, and just set the default value as, generating a random UID, and this would be fixed. Now, NHS upgrade stage, I don't know what this table does. I didn't dig into it, but again, I do the same thing. I'd change it to using the ID with UUID and generating a random ID, and the rest is pretty much the same. So just making sure we're using UUID across the board with generate random UUID. It's a bit cut, yeah. So in here we have the foreign key relationships. So I did the foreign key audit. Basically, we see the child tables based on the primary key. So basically, institutions containing the primary key, and then the foreign key column would be institution ID in institution updates. Now, everything is pretty good across the board. The only thing I'm seeing is there's no cascade and a little bit of a change needed on visitor events. So for the analytics, we can see that the on-delete behavior is a bit special, and that's what we've seen basically that I showed you earlier, that it's not going to delete the events for the users when their account is deleted. So that's maybe something to look upon. So then we have the data type audit that I do. So the timestamp is basically inconsistent across the schema. So it's using timestamps without the time zone and with the time zone, which is really not recommended. So I show basically in every table what do I see in terms of different timestamps used. So this is how you would fix it. The idea is to basically use timestamp Z everywhere, because what you can do is just store the time in UTC everywhere. So the UTC time is standardized, so it's always +0 anywhere you are in the world. And then what you can do is in your front-end application, just transfer that time from UTC to your local time zone, right? So this is way more effective, and you have less chances of storing a bad time zone that is mixed with other time zones. So again, I showed in the steps here on how to do this. Now we have some post-GIS geometry things that I made also here. We're not going to go through this because I don't think it's relevant for most of you guys. And the rest is, mostly like column types and stuff like that. So we're going to skip this for now. Constraints. So the constraints are pretty good. So usually when I review architectures, I don't see constraints on column, but this is a really good thing to have because it basically adds a bit of validation on your schema. So in this case, we see that institution as a description length of maximum 280, permanent node, stuff like that. So instead of doing this validation in the front end, you can do it at the database level, which is pretty good. So that's pretty solid. Now, I'm not going to go into every constraint that I've seen that could be added because this is some application logic, but also not null constraints. So basically some keys are nullable, which institution tags with the column institution ID would be nullable. This shouldn't be not null. This shouldn't be null because we want the institution ID to be fillable, right? Because otherwise the institution tag row doesn't mean anything. So for the whole schema health, basically what I do is I make a summary at the end. So the summary is the priority action items. So I made a P0 to P3 ranking of what's like the most important with the effort associated to it, and that's what he got for the schema health part. Now let's go to the next part. All right, so next part that we have here is the security part, right? So security part is really important because I feel like it's the most left out kind of thing in the Supabase, Postgres in general, or just any database, to be honest, or application. So in this case, I basically made a security and RLS policy report, and just showing what tables are accessible without RLS policies and stuff like that. I found some critical security issues. So like partner scans. Partner scans is mostly a ingestion table, so it's made to basically scrape the museums and store the results. So I put critical there, but actually like it is critical, but not as critical as a production table would be, because yes, it's accessible for anyone to scan, but it's not crucial in the way that it's going to make it where a table that is used by users every day is going to be leaked out to the public. But again, what I do is this is the current policy, so it allows basically anyone to read this table as they want, and basically they can do anything from reading, deleting, updating, inserting, whatever. So this is really not good. So what I suggested is basically drop that previous RLS policy and create a new one only for update or something like that, right? Same thing again for institutions. This is a bit more critical because this is a used table a lot. So basically, we only want to allow updating for the authenticated user. This is how you do it. You do using auth role authenticated. And we also want to allow update if basically the institution is owned by that specific user, because that's just logical. We want only the user that has the institution to be able to update it, right? And then otherwise we'll just remove the broad policy, which is just like a catch-all for anything else. So we'd rather use the one where it's authenticated. If you can prioritize an authenticated RLS policy, always do it before doing a permissive policy. Now, again, same thing here. We see that an authenticated user can insert institutions. Again, this is not necessarily bad. It's just that it inserts more risk than what is necessarily needed, because maybe an admin should be the only one that could be able to insert in that table. This is really an application logic question, but I basically flagged them that this is a concern. Just make sure that you're aware that anyone that is authenticated can insert. So I won't go through any of them, but it's the kind of permissions that can be watched. And I make, again, I give him a policy per table matrix. So basically, which table has policies and which should be added. And then after that, I have the priority action items, which I love doing at end of each report. So I tell him again the effort, the risk, the issue, and the priority in that specific rule that it needs to add. So let's go to the next section. All right, so next up, what I do is I make a performance/optimizations report. So most people will tell me like, oh, you don't need to optimize this database because it's small and it's not like there's not going to be any performance impact, even if there's, bad queries and stuff like that. And what I answer to those people is, yes, sure, but it's harder to, patch a canopy than patching a 40-foot yacht, right? So it's like you'd rather do it at the start and then grow and have already a healthy schema, and it's going to be easier to maintain than have to patch it later when you already have data and users and stuff like that. So basically what I did is I looked at the indexes and looked at what could be done with the indexes. If you guys don't know what an index is, you can basically go take a look at my video that I made. I'll try to put it in the cards here. But an index is basically makes it faster and more efficient to query data based on the specific query that you need to make. So basically, there's a few queries that he does a lot, and I know why he does it, because basically he has an admin UI for this query, which basically looks at the institutions he has in the database, and it looks at if it's active. And what it's doing right now is that it's using a partial index. So the partial index is basically just looking at the is active through basically data. So as you can see, that's how he does it. So he creates an index on the public institutions on the column is active, and looks at if is active is true, which it's not, it's not bad, but it's not the best, because you want only an index scan, which if you want only an index scan, you should just create an index like this and not add a condition. This way, every time you filter basically on is active, it will be way faster because it could see the false and the true. So this would basically reduce the total query time on top the top two queries by 30 to 50%, because it doesn't need to scan the whole table to find the is active rows, right? So then after, once again, we have a lot of calls to that specific index. So we can use a composite index on institution to use with the slug and is active. And basically what this will do is it will speed up the combined filler pattern, because a lot of times what will happen is you want to search for a specific institution and see if it's active. So this way you only have to query the index and not the you only have to query the index and not the whole table with a sequential scan. Like I said in my index video, you basically want to do as less sequential scan as possible, because those are very costly for CPU and memory. So you really want to reduce that. Now here we have the composite index for query and sort. So IMPAC. So it only has 10,000 rows. It's the largest table. And what it does is basically filters on the table name and if the field change, and it orders it. And it has only the primary key on ID. There's no index. And actually this caused 444 sequential scans, reading about 365,000 rows, which is a lot. And one query took almost like 3 seconds, which is a lot, right? So basically what you'd want to see is you'd want to basically have an index, because if you're, this is for sure for his admin view basically. So he has the way where you can track the table updates. And basically what you'd want to store is just an index of the table name and the change that already ordered, right? Because the thing is, if you basically have a view where you want to know what's the most recently edited table, then you can just query that index and you're going to get it super fast, right? Compared to if you basically have 10,000 rows and you're looking at a specific table, not only it needs to filter by the table name, but it also needs to sequentially scan through every row to see what's the most recent change that date, which is pretty expensive because it needs to compare every date to each other. So again, a few examples of what I did. I won't go through any of them. There's also the index removal. So sometimes it's adding indexes, sometimes it's removing indexes that are not used, and that takes place for no reason. So I won't go through any all the indexes, but I made a section also for vacuum. So vacuum is basically Postgres. The way it works is it creates tuples, and they call it dead tuples. So when you shift data around, it basically uses it in the buffer, and after a certain while, those, they call them dead tuples, they basically need to be cleaned from the database because they're not needed anymore, right? So as you can see, I made a summary of the dead tuples per table. As you can see here, we have the percentages of the dead tuples. You can see it's a lot. Usually you don't want to have like that much dead tuples for a table. So what you can do is tweak the Postgres parameter to basically run the auto vacuum threshold more often. So the auto vacuum is just gonna go through the table and delete the dead tuples based on the rules you set, which is a lot of people don't use these because they don't know what the auto vacuum is, and it makes sense, but just something to be aware of if you want to keep your database the most efficient as possible. It's also going to take less storage, so that's another good thing. Now, again, I talked about triggers a little. So triggers are basically event-based actions that you can do in a database. So you can see there's duplicated database. So there's the updated at and set updated at, which basically does the same thing. So again, you'd be setting the date, the updated at 2 times, which is unnecessary. I also love to do a partitioning assessment, but in this case, the user doesn't have any partitions, so it's not, it's not something that is applicable to him. But in the next architecture review that we'll do, we'll check some projects with some partitions, which will be interesting. Again, here RLS policies. That's a bit of a, out of topic for this page, and then the query level observation. So in one of the queries I asked the user to run, I basically asked him to give me the most expensive queries. He does a lot of select star, which is not the best, but for the size of his data, it's not bad either, because it's not big enough. But I basically make a summary again for the priority action items that he should do for the optimizations. So here it is in terms of order. I think it's not that bad, but it's definitely easy stuff that you can do that will be done quick and are gonna show real results instantly, right? So let's skip to the next section right now. All right, so the last segment of my analysis when I do it is basically the scalability factor. So what is the situation right now, and what do I forecast for the future of this database? So right now, like I said, it's pretty simple. So 14 megabytes. This is as of May 2026. The audit log table is the largest table. So it has, 11,000 rows. And the biggest table is the spatial ref sys table, which is for PostGIS, the system. And central table, the one we want to put most attention to, is the institutions table, which is 1,000 rows. And basically we can track the other stats that I've put. So 1.4 million calls for the API, 115,000 calls on institutions, and 80 total tables. So what I love doing is basically doing a growth projection across what I think the tables will look like in the future. So if you basically use the 2 tables I mentioned here, so audit logs and visitor events, which have a lot of volume. Audit log, I basically mark down the 11,000 for the current rows, but I also explain the growth driver that could make it unreliable. So let's say there's 5 to 20 rows per institution edit. So let's say they want to change, phone number, the website, the opening hours, stuff like that. This will add a lot of rows. So at this point, you need to do the optimization, the speed optimizations that I showed in the previous thing. Same thing for the visitor events, right? If there's going to be, a new row every page view or every QR code scan, it's basically going to be, 1,000 to 10,000 rows a day, which is going to grow fast. So you need to make sure you have, at this point, you need to make sure you have partitioning indexes, because otherwise it will become unsustainable for data collection after that. So again, this is, the tier 1 growth projection. Longer term, I see also other things. So those are like no action needed soon. Nothing that's needed to be done right now. But again, adding new QR codes, new museums, stuff like that. So this is going to grow very slow, but you still need those indexes that I showed to be able to manage those. Those will probably stay static. Makes sense, because you won't add tags or profiles that much. You add users, but it won't grow as fast as events or stuff like that. And now we have also the trigger overhead. So basically the way a trigger works is it executes after or before. So usually what happens is a trigger is not asynchronous. So if you do before update, is basically going to need to execute a trigger before the operation itself. So it's going to reduce the speed of an insert. So again, you just need to make sure it's not, slowing down your It's not slowing down your operations. If you know you're going to be doing a lot of changes at the same time, so let's say you're updating a bunch of institutions at once, you could just disable the trigger temporarily and reactivate it after. And then after that, just make sure that if you're using the Postgres institution profile call, so basically what's going to happen is, since this is a directory, some institutions will have their profile viewed a lot of times. And since it's always the same data, what he could do is from the tables create a materialized view that basically only stores the columns he needs. So he doesn't need to query the database every time, right? Because a view is basically stored in memory and is always the same format and just updated as you update the base table, right? So it's way more efficient than just querying the table directly for exactly the same data. All right, so let's continue now. Ready for growth. Like I said, the factors, there's still some pretty good things. So UID primary keys, that's pretty good. No risk for big int or int, stuff like that. Bilingual columns, and he's in Canada, so that's good. Junction tables, like I said, so that's pretty good. That's basically when you have a many-to-many relationship and you're not able to store them into tables because it's the cardinality is too high. So what you do is you basically have a primary key, then a table with two foreign keys, and then another table with a primary key. Now again, I told him a little of areas that may need structural change, but it's not that crucial. Other things that he could do is full text search, because he searches a lot for name descriptions or institution names, descriptions, their locations, stuff like that. So when you're in a search bar, you basically want to use a full text search index to search faster, right? We call this fuzzy search, and if you don't have an index, it's going to be a bit slower than if you're using something like the extension tsvector that combines the algorithm BG25 to basically allow full text search. So also I told him about the Supabase plan consideration. So there's no problem right now with the free tier, but I just wanted him to know that he's going to need to go to the pro tier when he reaches those. But for the current usage, he's way good. And then a summary for this. Now, the thing I do after, I'm going to show you. So I basically have two things. I have the summary for customer. So summary for customer is basically the more business-oriented summary. So things that should be done soon, that needs to be done in the future, stuff like that. And I have the technical summary. So this is everything I've showed, but basically concatenated in one with the most important outlines. So again, if you guys would want your architecture reviewed, you guys can go to my website, submit your email address, we can get in contact, and I'll basically review your website free of charge. It's, like I said, it's mostly for analyzing and finding patterns. You can choose to give me access via the developer console to your project, or you can run like 8 queries that I send you, and I make you your report in about 2 to 3 days maximum. And then you're all set. So if you guys have any questions, leave them in comments. Otherwise, I'll see you guys in the next one, and peace out.